All right, guys, I'm uploading this video because a lot of y'all were having trouble with this assignment. Now, we did start on motion graphs Tuesday before your guys' Wednesday holiday, and unfortunately, Thursday and Friday I'm out. So, you are really going to be needing to rely on your notes that we used in our Google Classroom um, under graph changes and motion and then motion graph introduction notes, and it's the blue Google Slides that I had everybody pull up on Tuesday called Graph Interpretation PPT. Okay, so those were the notes that you were going to need for this assignment. All right, so now jumping in, motion graph practice questions. All right, so you were given one, two, three questions, and these are just simple definitions that we've gone over already. An object is in motion when its distance from a reference point is changing. So that is like whenever I said I am starting from my desk and I am walking across the room to the other side to touch the wall. I have now changed where I started from. I'm starting from point A and I've ended up somewhere else. Okay, so I'm in motion when the distance from the point, the origin, is changing. Number two, speed in a given direction is called velocity. So we did talk about this about 2 weeks ago whenever we were going over forces in motion, speed, acceleration. Velocity has a direction. It's like saying Miss Graham is traveling in her car going 10 miles per hour east. East gives me that velocity. It is a direction, north, south, east, west. And then the last one, speed can be calculated if you know the distance that an object travels in 1 unit of time. So we've used our STD triangles plenty of times. So if we have a given distance and we are given the time, we can calculate speed. All right, so now let's move on to the harder stuff. Number four, which of the following graphs shows runners moving at the same speed? Now I needed you to explain and show your work, mainly just explain. All right, so looking at these four different graphs, we need to figure out which runners are moving at the same speed. So we can see graph A, we're starting at 10 and we are increasing going up and we're ending at the same point. So these runners are not going at the same speed. This line is going up faster than the second runner right here. So they're running at very different speeds. And then graph B, they start at the same point. However, you can see it is taking this runner a very long time to reach its point versus runner number two has reached its point faster. So they are not at the same time or at the same speed. Now, graph C, one runner starts at 0, one runner starts at 10. The first runner shoots up. He has made it there in less time than runner 2, which is kind of like a steady pace. Okay, so they are not at the same speed. So this is why graph D is our answer. So they start at different points. However, if you see these lines, they are identical. They have the same slope, which is that rise over that run. They're identical lines. So these runners have the same speed.